12 questions. I really enjoyed this lesson. It was way easy.
That's good because I might need some help. I was so confused by that little applet thing this time.
Oh, yeah?
Like, I just didn't understand. Like, I read it probably 4 times. I just really didn't understand where the data was supposed to go to make it work.
Right.
So question 8 was really hard for me. Like, I kind of figured that the first 2, like A and B, were both normal, but I don't know. Like, I really don't remember or understand how we got those numbers out of that question. Yeah, what are you doing?
So hopefully it'll be something in the quiz so we can.
Right, for sure. So let's.
Okay. About it.
Stop it.
So you ready?
Yeah, almost. Left back open. Yeah, the more I move this cat, the more insistent she is that she wants to be on my computer. Start quiz, let's see. True and true. Okay. Do not round until your calculation is complete.
Okay, so the first one says when you're taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is right skewed? So that is going to be, the distribution of means is going to be skewed right.
Right. So it just.
What?
That was my other question. So it's always going to be skewed the same as the parent population. It's not ever going to be opposite.
Unless the sample size that you're taking is above 30.
Okay. Right, because then it just becomes more normalized.
And I think in the textbook they like normalized, like, because 30 is just like a rule of thumb, and so they just said in these lessons that if it's 30 or above, then the distribution should be normal, even if it's skewed to the right.
Okay, so then in question 4, since our sample size is 100, it's normal, correct?
Yeah.
Okay. In question 5, when you are taking a sample size of n equals 5, what is the distribution of means histogram when the parent population is normally distributed? That would be normal, correct?
Right. Because the distribution itself is normal.
It doesn't have to make up for it with size or anything.
When you are taking a sample size of n equals 100, what is the shape of the distribution of means histogram when the parent population is normally distributed? It's
normal. When would the distribution of means be normally distributed? Choose all correct responses. Data are drawn from a population that is normally distributed, and then the sample size is small, so that is true.
True. Data are drawn from a population that is normally distributed, and the sample size is large. That's true.
Data are drawn from a population that is right skewed, and the sample size is small is false.
That's false.
And data are drawn from a population that is right skewed, and the sample size is large. That is true too, right?
Yep.
Okay. So not focus all on what I was freaking out about. This is good.
Which of the following gives the best explanation of the central limit theorem? If the parent population from which the data are drawn is normally distributed, then the sample mean will follow a normal distribution. The other one talks about the 68, 95, 99.7 rule. If the sample size is large, the sample mean will be close to the population mean. If the
That's
sample size is large, the shape. What?
so that's the large numbers rule, isn't it?
Yeah.
Okay.
If the sample size is large, the shape of the distribution of sample means will be approximately normal.
That's it, right?
Information.
No, I'm back. No.
So the law of large numbers is the third one because it talks about
right. Because it becomes closer to the population.
No.
No.
I'm torn between the last one and the first one.
So So the theory of large numbers has to do with distribution being more regular, right? So it doesn't matter if it's right skewed or left skewed. The central limit theorem means that has to do with accuracy, doesn't it?
No, I think that you got them backwards. So the law of large numbers talks about the spread of the distribution, like how it's dealing with like the mean, and I had this all figured out yesterday.
So if I'm looking at the homework answer key right now, and it says the central limit theorem states that if the sample size is large. You're right. Okay, I am backwards.
So that's why I'm torn between the first one and the last one, because they both talk about the distribution. The parent population is normally distributed, and the sample mean will follow a normal distribution. So that's true.
Mm-hmm.
If the sample size is large, the shape of the distribution, I think it's the last one, because both the central theorem and the law of large numbers talk about the sample size being large, but the theorem talks about the distribution and the shape, and the law of large numbers talks about the spread.
All right. Yeah. You're right, then that makes sense.
So I think it's the last one.
Mm-hmm. I agree. And if not, we have a second try.
Right.
All right. Use the following information to answer the next 4 questions. Oh, wow. All right, duh. Let X be a random variable with a population mean of 10 and a population standard deviation of 6. Suppose a sample of size of 36 is drawn from this population. So, number 9 is what is the mean of the distribution of sample means? So that's the one that we use formula for, correct?
No, you need the formula for the standard deviation of sample.
Yes.
Of sample means. Right. Yeah, because the mean is the same as the mean of the population mean.
Right. Yeah, I knew that. I did know that one.
And then the next one is what is the standard deviation of sample means? So that is the formula, and that is the standard deviation divided by the square root of
so it's going to be 1
size. Yeah.
6 times 6 is 36.
Yep.
Cool. Regardless of the distribution of the population, if the sample size is large, over 30, what would the shape of the distribution of the sample be? Normal. Got this. What theorem would justify your response to the last question? And that one's the law of large numbers, right?
Oh.
Backwards.
Yeah, I think it's the central limit theorem, because you're talking about the distribution and the shape of what the sample mean is going to be instead of like the spread.
Nope, you're right. Yep.
All right. Saving and submitting
See how we did.
and submit. We got 100%.
Okay, so I'm gonna go and like study this quiz and make sure that I've got the law of large numbers and central limit theorem straight in my head, because it's always gonna get screwed up, I think. Well, cool. That was
Awesome.
the best, shortest video we've done so far.
I know.
So then what was the point? I really don't understand the point of the applet. Was it just to show us, like, prove to us that it would be normal and like kind of show us how it was working then? Like,
yeah.
Okay. Fine.
Just the way that I was a little confused by it, but yeah, it's just showing like the mean of all these samples is going to end up as a normal distribution.
Okay, good. Good. I was sitting there. I read it so many times thinking, when am I going to figure out what this thing is supposed to do for me? That makes a lot more sense. So good.
Awesome. Well,
so we're meeting 15 next week?
Thursday.
Thursday. 12:15. It's sort of there.
All right. We'll see ya.
Have a good week or couple of days. Bye.